My little gasket's getting... Say that again. What about? Brittany, go. What are you thinking?
I don't know.
Would it be helpful to pull off those lines?
Yeah.
Maybe it's hard to see when you have the two lines in front of you. Oh, how many, if we were picking points, 2 at a time, do you see how many different lines we could have? I mean, if you just look, suppose you pick these 2 lines right here. Or those 2 points right there, you end up with that line right there. I don't think anybody's going to pick that line. That seems too flat. It picks the least steep rate of change and calls that average. That seems kind of silly. Seems kind of silly to do that. So good, Brittany, what Brittany's doing. Now here's the thing. I want you to stop right now. Because, believe it or not, the best fitting line for the data doesn't even touch the data. That's the best fitting line for the data. That's the best fitting line for the data. That's the best fitting line. Now it's close to what we did. It's close to Tammy's, isn't it? It's close to Tammy's 1.125 plus 32.75. It's probably close to Ian's. The slope is actually closer to yours, right? Because your slope was exactly 1.05 though. And you might say to yourself, 1.05, but you got to remember, that's millions, right? 1.05 million, which means the 0.05 is 50,000 extra people that you might not want to just like, it's like the entire population of Delaware. Forget them anyway, nobody can find it on a map. Yeah, please.
You can't come up with that looking at it.
You can. You can. It requires that.
Yeah, well, I'm never going to...
Well, no, you're not. You're not going to do that.
That's what this is
Tip off that slide.
Can we? I'm not doing it.
Randall asks, can we? Yes. And if you're interested, I have the justification of those formulas for you. The problem with it is, this is a problem. Modeling is part of the curriculum of Math 105. This wonderful set of equations that's over here, this wonderful, wonderful set of equations, relies on calculus to derive. And because calculus is not a prerequisite for Math 105, we can't do it manually. Because you have to do something called a partial derivative in order to actually extrapolate those equations from the setup. So yes and no. If you want, I'll send you the document. Happily. Just remind me to do it. But here's the deal. That is the best model. Now, I'm kind of a stickler about this too. When you give a model like this, you should additionally always list what the variables are standing for. So if you just give somebody an equation, y equals 1.05x plus 33.1, that's a fantastic equation. The problem is, unless you know what x and y are, you've lost the meaning of what you're studying. Now, if you have it on the graph like this, you're done. Because the graph itself shows you, oh, x is years since 1990.
So are you like...
And y is the millions of people. Go ahead.
Are you ending up using all the dots to make the best fit line in...
You know what you're doing? That's a fantastic question. Brittany asked a very, very good question. Are you ending up using all the dots? I'm going to leave it up there with everybody else's lines. What that equation is doing is it's measuring... What color haven't I used yet? I haven't. I've used them all. I'll use black again. What this does, Brittany, is it measures all of that offness, all those residuals, and it minimizes the sum of them. Actually, it minimizes the sum of the squares of them. And the reason why it minimizes the sum of the squares, this is something a little 243-ish. You see how some are above and some are below? That means some are positive and some are negative. If you add negatives and positives, they cancel each other. So you could have a really crappy line that misses almost everything, but if the ones above and the ones are below are perfectly balanced, they're going to knock each other off and make 0, which it's going to make it look like there's no difference. So what that mathematics is actually doing up there is it's taking these distances and it's making little squares off of them like this, and it's measuring the areas of those squares, and when it gets down to the smallest value of those areas, you've got your best fit line. And that's why the formal term, Taryn, I believe it was used as best fit line. It was Francis. The technical term is a least squares regression line. And the reason it's called least squares is because it's actually measuring those squares. I've got a video that explains it. I have it linked to your extra resources page. There's a video that explains it all pretty well. I think I even use this data to explain it. But the problem is the mathematics of that is pretty heady. That's what those equations actually do. It's the sum of those squares minimized. And the minimization is what makes it a calculus problem. Whenever you have to make something as small or as big as possible. Yeah?
I was just going to say, can't you just do that and protect it?
That's what we are going to do. So how many of you have done least square stuff or best fit line stuff before? That's always what happens, roughly a tenth or a half of the or a fifth of the class. So what I've done, and what we'll do today, right now, is I want you to use your TIs to do it. Now, what I've done is I've made a little booklet for you. So grab one of these and hand it back. I'm going to keep one so I can refer to it myself. This is for the TI 83 and 84. If you, yes, perfect, you already got it. Now, what? Well, if you don't, there are other options. You could probably download a freebie on the App Store. I'm almost positive you can actually. The only problem is I might not know how to run that. I could probably learn it pretty quickly. So if you guys with smartphones want to download one, that's totally fine. You have other options. You're never going to be sitting in this class in a time situation doing this. So you can always download the emulator that I told you about on the first day of class on the materials page and run the TI on your computer. You can totally for free. That's for free. Which means you can then use these instructions. You can also find an app in the Apple Store. That'll probably work just fine. I just got to know how. I just got to know how to do it myself. I don't know how to run those most likely. Actually, I'll look for while you guys are working. I got my phone with me. I'll see if I can find some freebies for you guys. Okie doke. So take a few moments right now. Take a few moments right now. This data. Oh, the way it's set up, it's a booklet. So you can actually fold this thing into a booklet. If you're looking at the page where in the top right it says using the TI-83/84 to create a scatter plot and perform a linear regression, just fold that bad boy behind it. So that's page 1.
Page numbers on it.
Yeah.
Oh, I was smart enough to do that. Yay. Good. I put page numbers. Yay. And I printed it correctly, which is not always a given. Sweet. Sometimes I print the wrong print button. I end up getting 4 pages for each person, which is highly annoying. So anyway, got some extras? That's a leave them over there. We'll come get it, Michelle. So there you go. Just take your time now. Take a few moments. I mean, take some time. Like I said, I'm going to try to find some apps for you guys so we can dig up.
Oh, I don't know.
Well, that's okay too. But the point of this is, in case you've never done this kind of thing before, now you can. Now, it's broken into, I think, 3 parts. It's entering the data, it's making the scatter plot, and then it's doing the linear regression, which is actually finding the equation of the line. The first part of entering data, you probably don't have to do more than 1 time, because it's the idea of that one is trying to get us all back to square one. We've got blank Y1s, we've got our lists turned on, and all that stuff. So take your time, work through it. Hi.
These numbers are the numbers that are on?
They're the same ones. Oh. These numbers match the ones I just was looking at with you guys. So I was trying to keep it somewhat consistent.
Yeah.
Okay? So take your time, work through it. I'll be around if you need me.